Lesson 1-8, Cracking the Muffin Code. So on this first day, I'm going to help you solve a problem about codes based on place value structures. So let's do some mental math and fluency. Give the next number in this sequence and share your reasoning with a partner. You should be looking at how does 1 become 3? Well, it could become larger by adding 2. But then 3 plus 2 is not 9, so that can't be my answer. Well, how else can 1 become 3? Well, hopefully again you're realizing in 4th grade that we really stress learning your multiplication facts. So 1 times 3 is 3. 3 times 3 is 9. 9 times 3 is 27. What is 27 times 3? Remember, if you don't know how to multiply very well, you can use repeated addition. So 27 times 3 would just be 27 written down 3 times. Pause the recording now, figure that answer out, and then play again to find your answer. You should have came up with the number 81. Please get out your math journal and turn it to page 19. I want you to complete journal page 19, and then I want you to turn back on the tape and see if your answers work out with what I'm about to tell you. So pause the recording now. The information says, at Barbara's Bakery, Bob packs bagels into boxes that hold 25, or the box might only hold 5, or a single box that only holds 1. Bagels come to Bob on a tray. Bob always fills the largest box possible and makes sure each box is full. For each tray of bagels on the next pages, how many boxes of each size does Bob fill? So complete journal page 19 and then discuss your answers with a partner. And let's take a look at this. We said that Barbara's Bagel Bakery, Bob packs the bagels into boxes that hold 25 bagels, 5 bagels, or 1 bagel, depending on the size of the box. So looking at the first one, 27 bagels. How could he get 27 bagels? Well, he had 1 full box of 25, 0 boxes of 5, and 2 boxes of 1 bagel. That way, 25 plus 2 equals the 27 that we're coming up with. All right, how did you find the number of bagels for the second row? Well, in order to get 10, we couldn't use any boxes of 25. We could use 2 boxes of 5, which is 10 exactly. And then we don't need any boxes of 1 bagel. So 2 times 5 is 10. And we should have it completed. How did you figure it out for the next row? Again, if you realize you've made some errors, pause the recording now, fix them, and then turn it back on so you can double check your answers. 53. Well, that's 2 boxes of 25, which is 50. I have 3 left over, so I won't have any boxes of 5, and I will have 3 single boxes of 3. So 50 plus 3 will give me 53. And for the final one, 9, well, I won't have any boxes of 25. I will have 1 box of 5, which leaves 4 left over, so I'll have 4 single boxes. So 4 plus 5 gives me the 9. Remember, when you answer these type of questions, you're using what's called mathematical structures to solve the problem. Mathematicians use mathematical structures often when they look at patterns to help them make sense of a problem. You are going to use patterns and mathematical structures to solve more problems like this one. For this next step, you're going to need Math Masters pages 29 through 31 out of your math file. So please pause the tape and go get those now. The Marvelous Muffin Market customer buys muffins in boxes of 27, 9, 3, and 1. Their task is to make sense of the problem and use mathematical structures to figure out Marcus's code for how the muffins are packed into boxes. So you're looking at Math Masters page 9 here. I want you to ask yourself, what code are they using? Understand that a code is typically a system of letters, numbers, or symbols that gives information about something. We use codes all the time. We use zip codes and addresses, or barcodes on different packages of items we buy. Cracking the code simply means figure out what the code means. When Marcus took an order for 5 muffins, he wrote a code of 1 followed by 2. That code is related to the number of boxes Marcus's will need. Work with a partner and try to figure out what the code means. If you need to, stop the tape now to replay it and back it up again, or stop the tape now and just figure out what it means, and then we'll go on. So what did the code mean? Marcus will fill 1 box of 3 muffins, and then he will fill 2 boxes of 1 muffin. Remember, we're not using the same code that we used before. I said that we were starting a new code. So the code 1-2 means 1 box of 3 muffins and 2 boxes of 1 muffin. Ask a partner to work with you to explain the next 2 codes. And after a few minutes, as partners, I want you to come back and share your explanation with me. What do Marcus's codes for 19 muffins and 34 muffins mean? Remember, now you're on page 29 of your Math Masters loose leaf sheet that I've been working with. Pause the tape now and do that, please. So, how many muffins were ordered? According to Math Masters, page 31, hopefully you figured out it was 32 muffins. So what is the largest box Marcus can fill? Well, a box of 27 muffins. Could he fill boxes of 27 muffins? No. So what is the first digit you should write in the code? The number 1. Why? Because he can fill 1 box of 27, but not 2 boxes of 27. So what's the next size box? Well, a box of 9 muffins. Can he fill a box of 9 muffins? No. So what should he write next in that code? Correct, a 0. So what should he think about next? Well, he should think about how many boxes of 3 he can fill. He has 5 muffins after filling the box of 27, so he can fill 1 box of 3 muffins. Continue with this until you finish page 29. So remember, everything that I've been doing with you here so far has been on page 29. All right, Now we're looking at what size boxes does Marcus use to pack the oat squares. You're going to be using your other sheet for this, and it's asking you the size of boxes, so you're looking for the words oat squares. Stop the tape now and make sure that you're finding that. Hopefully you found that on page 30. So, what size boxes does Marcus use to pack the oat squares? Pause it, figure it out before you come back to it. Pause the recording. Hopefully you noticed that he packs the oat squares in boxes of 100 and a box of 10 or a box of 1. So for 17 oat squares, which boxes would he use? Stop the tape now and figure that out, and then turn it back on when you're ready. Pause this recording. Well, 1 box of 10 oat squares and 7 boxes of 1 oat square would answer that question. For problems 4 and 5, the goal is to see what you can figure out on your own. And then we'll discuss this tomorrow, and we'll try to look at the responses to problems 4 and 5. Now remember, you need to persevere, meaning keep going, keep trying. Stop and rewind this recording if you need to try to figure out the answers. Try to ask yourself, well, what am I doing? Or what could I be doing differently? Is the way I'm figuring this out helping? Is there a different way I could figure out? Remember, you can ask another person for help. So you need to ask yourself, in Marcus's codes for muffins and oat squares, what do you know about the first digit on the left compared to the digits in the other places? Pause the tape now and see what you and your partner come up with. Compare your answers, and then turn this back on. You should have noticed that the first digit always tells you the number of the largest boxes to be filled. What does the last digit always tell you? Stop the tape now and discuss this question. You should have noticed that the last digit always tells you the number of smallest boxes to be filled. So why does it matter where the digit is placed? Stop the recording now and discuss that with a partner. Again, why does it matter where the digit is placed? The reason it matters is because the placement of the digit tells you the size of the box. I'm going to stop the recording now, and I'm going to continue it on another recording.